Hello and welcome to our channel again. So this is the second video where I will discuss about the applications of the vector operators. As in the first video, we discuss about the vector operators and what exactly the vector operators are. So in this video, we are going to discuss about major three applications of the vector operators. And the three major applications are the gradient, divergence, and curl. So we are going to discuss all these three types of applications of vector operators. So here I am Suraj Singh and let's start the video of applications of vector operators. So here the first applications of vector operator. So the first application of vector operator is what known as the gradient. What known as the gradient. This is the first applications of the vector operators. So what exactly this particular gradient is? So to understand it, first of all, I will write the formula of the del operator or the vector operator so that you can understand its meaning in a deep way. So the formula of the vector operator is given like this, that this particular vector operator formula is equals to the partial derivative del by del x. It is called del by del x I cap plus del by del y j cap, and similarly in the z direction it is del upon del z k cap. So this is the formula of the vector operators. So let's understand this. The partial derivative of whatever function you will apply to this particular vector operator with respect to x, y, and z axis. So this is the particular formula of the del operator or the vector operator. So please keep this formula in mind, as this formula is very important while we are discussing the applications. So now we move towards the talking of the gradient. So gradient, what is that? Gradient has some very important properties which we are going to discuss. So first of all, its first property we are going to study is that if there is a scalar function, let's say I will assume that scalar function is phi. Okay, so there is a scalar function phi, and when we apply the nabla or the del operator to that particular scalar function, it means what happens is that when I will apply the nabla operator to it, when we apply this particular del operator, to that scalar function, we will get a new quantity, and this quantity is not the scalar quantity. This quantity now becomes the vector quantity. Despite of this, that previously it was a scalar quantity, but here's a twist. The twist is this, that when you apply this particular del operator to the scalar function, it will results the vector quantity. It means it has some sorts of direction also. Yeah, it has direction. Now comes the real game. Then the direction of this particular vector is in the maximum increase of this particular scalar function. Maximum increase, this is the maximum increase of that particular scalar function. So the direction of this particular vector quantity that is obtained by taking the gradient of this scalar function, and its direction is in the maximum increase of that particular scalar function. So we have studied, yeah, this is the game, that when we apply this particular operator to a scalar function, we will get a vector quantity and its direction is in the maximum increase, and the direction is in the maximum increase of that particular scalar function. So let's take an example to understand this in a good way. So the example is very simple, and let's take the example of the temperature, which is a very commonly used example to explain the gradient, as it fits very clearly. So this is a temperature. Okay, so temperature may vary from points in a room. So let's take an example that you put a heater in one corner of the room and turn on the heater. So the heat is started emitting from that particular heater. So when the heat is started emitting from that particular heater, the thing is that the temperature is maximum at that point of the heater where heater is kept, and minimum when where there is the door or where there is a window. Yeah, that's okay. So what the del operator will do in this case is that when we apply the del operator in this case, that taking the gradient of this particular temperature will result that what is the maximum increase of the temperature at a particular point, at a particular coordinate point. This what's the gradient will do. It means when you take the gradient, when you take this particular gradient of temperature somewhere near the window, somewhere near the window, somewhere near the window, so when we take the gradient of this particular temperature near the window, near the window, what we will get is that the direction of this particular vector operator obtained by taking the gradient of the temperature is that the direction will be from the, you know, away the window. The direction is from the away the window. It means the direction is in the maximum increase of that particular temperature. So the maximum increase of that particular temperature near the window is away from the window, inside the room, not outside the room, because that outside the room the temperature is decreasing continuously, because the effect of heat is not same as in the room or the outside. So when you take the gradient of the temperature near the window, you will get that the gradient, you will get that the direction of this particular temperature will inside the room, will inside the room, inside the room, the direction of this particular temperature gradient is. So let's take it with an example. Let's explain it with the graphic. So here I have made a graphics that at this corner there is an heater, and this corner there is a window. So when you take the gradient of the temperature at a point which is very near to the window, at a point which is very near to the window, when you take the gradient of the temperature, you find that its direction will be in just away from the window, just away from the